If we are asked to multiply fractions, a good idea would be to reduce our fractions as much as possible before the multiplication takes place. In order to do that, we use a technique called cancelling. And what we do is any numerator and any denominator that has a number in common, a factor in common, we use that to reduce. After we have reduced as much as we can, we go ahead and multiply our fractions. Let's look at an example. If we are going to multiply these two fractions, the important thing that we try to do is to see if there's any numerator and denominator that can be cancelled. So what I do is I look at my numerators, look at my denominators, and recognize if there are any two of them that have something in common. In this case, there's no number that you can divide both 2 and 7 by or 2 and 5 by, and without a remainder except 1. So therefore I can just go ahead and do my multiplication straight. If I'm multiplying, I just multiply my numerators. 2 times 2 gives me 4. And then 7 times 5 gives me 35. Therefore, this fraction is simple. Nothing could have been cancelled out, so I just multiply my numerator. 2 times 2 gives me 4, and then 7 times 5 gives me 35. So 2 over 7 times 2 over 5 is 4 over 35. Here's another example. I'm asked to multiply this. 8 over 9 times 3 over 4. Again, my idea is I want to look at my numerators and look at my denominators and recognize if they have something in common. When I look at it, I realize that there is something in common. For example, the 3 and the 9. Both 3 and 9 can be divided by 3, so I can use that to break down these numbers and make it simpler. This is what is meant by cancelling. The same thing happens with the 4 and the 8. The 4 and the 8 recognize both of them can be divided by 4. And if I do that, I will get a simpler set of numbers to work with. So let's try this. 3 into 3 goes once. 3 into 9 goes 3 times. Notice I just divided both 9 and 3 by 3. Same thing for the 8 and the 4. Both 8 and 4 can be divided by 4. So I do that. 4 into 4 goes once. 4 into 8 goes 2 times. Notice I have simpler numbers to work with. There are nothing else that can be cancelled. I have a numerator of a 2 and a 1 now, and a denominator of a 3 and a 4 and a 3 and a 1 now. So what I do ahead is go ahead and just multiply my numerators, multiply my denominators. So 2 times 1 gives me 2, and 3 times 1 gives me 3. If I did not do that, I would end up with fractions that I would have to simplify in the end. Large fractions which I would have to simplify in the end. Therefore, the best technique to use is to cancel as much as you can. Okay, let's try out another example. 5 over 9 times 3 over 8 times 4 over 15. This example demonstrates why cancelling is so important. It will be very difficult to do this problem by multiplying 5 by 3 by 4, get a large number, and then 9 by 8 by 15, get a large number, and then simplifying the fraction. It is best to simplify the fraction first. Once again, what I do, I look at the numerators and the denominators and look to see who has something in common. When I look at it, I realize 5 and 15, both of them can be divided by 5. So I do that. 5 into 5 goes once, 5 into 15 goes 3 times. Now notice I have a 3 in my numerator and a 3 in my denominator, so I can do the same thing. Both of them can be divided by 3. 3 into 3 goes once, 3 into 3 goes once. Now notice my 4 and my 8. My 4 and my 8, both of them can be divided by 4. 4 into 4 goes once, 4 into 8 goes 2 times. And now I'm left with a 1, a 1, a 1 in my numerator, a 9, a 2, and a 1 in my denominator. That means nothing else can be cancelled, so I can go ahead and do my multiplication now. 1 times 1 times 1 gives me 1 over 9 times 2 times 1. 9 times 2 is 18. 18 times 1 is 18. So my answer is 1 over 18. Again, the key point is try to cancel as much as you can, try to simplify as much as you can before you do your multiplication of your problem.